In this video, we explore how energy works in simple harmonic motion, SHM, using a spring mass system. You'll learn that potential energy is maximum at the extreme positions, while kinetic energy is maximum at the center. As the object oscillates, energy continuously transforms between kinetic and potential forms, but the total mechanical energy always remains constant. This simple concept helps you understand why motion in SHM is smooth, periodic, and perfectly energy-conserving. We derive the expressions for kinetic energy, potential energy, and total mechanical energy in simple harmonic motion, SHM. Starting from the basic SHM equation and displacement x equals acos, t plus phi, we find velocity and use it to calculate kinetic energy, while potential energy is obtained from the restoring force of the spring. By combining both, we see that total energy remains constant and equals. This proves that in SHM, energy continuously transforms between kinetic and potential forms while always being conserved. We explore the real-life applications of simple harmonic motion, SHM, and how it appears all around us in everyday life. SHM is a type of motion where an object moves back and forth about a mean position under a restoring force proportional to its displacement. From swings and pendulums to mass spring systems, tuning forks, and clock pendulums, all follow this motion. These examples show that SHM is not just a theory but a fundamental concept that explains many natural and practical phenomena around us. Simple harmonic motion, SHM, is a type of motion where an object moves back and forth around its mean position under a restoring force proportional to displacement. It has key features like periodic motion, constant time period, and smooth oscillation. In real life, SHM can be seen in swings, simple pendulums, mass spring systems, tuning forks, and clock pendulums. These systems continuously move between extreme positions while passing through equilibrium. The displacement time graph forms a sinusoidal wave, showing regular motion. SHM is widely used in timekeeping, sound production, and mechanical systems. It helps explain many natural and man-made oscillations. From playground swings to clocks, SHM is present everywhere. It is not just theory but a practical concept in daily life. If you enjoyed this video and found it helpful, don't forget to like, share, and subscribe to the channel for more easy and interesting physics content. Your support helps us create more videos just like this. Stay tuned and keep learning, because physics is everywhere around us.